Welcome to Study Loop.
This is chapter 21, problem number 50. We have an RL circuit, and we're given the fact that it takes 2.56 milliseconds for the current in the circuit to increase from the initial value of 0 to the final value of 0.75 amps. And we're asked to calculate the time constant. This one's a pretty straightforward one, right? So let's remember how the current varies. I equals I naught, the maximum current 1 minus e to the power negative t over tau. We're looking for the time constant here, tau, right? So now assuming that our current is 75% of the maximum value, so it would be 0.75 times I naught, right? At a time, what would happen to our tau, right? So then I naught 1 minus e to the power negative t over tau. So these are going to cancel. And then we have 0.75 equals 1 minus e to the power of negative t over tau. So let's take this term to the other side. So e negative t over tau is going to be equal to 1 minus 0.75, which is 0.25. Now we take the ln of both sides. So ln e to the power negative t over tau equals ln of 0.25. So then left-hand side gives us negative t over tau. Right-hand side gives us just the number, right? So if we want to take tau out of this equation, then we have negative time over ln of 0.25. So when we plug in the numbers, we can calculate the numerical value of the time constant. Again, the time given to us is 2.56 times 10 to the power negative 3 seconds over ln of 0.25. Then we find tau to be 1.85 times 10 to the power negative 3 seconds. Now, this was the answer to part A. In part B, we're asked what the resistance would be for that particular tau and for an inductance of 31 millihenries. Let's convert that to henries, right? So this is straightforward. Once we know the time constant tau, as you know, for an RL circuit, it's going to be equal to L over R. So we want to know what R is. Let's isolate that out of this equation. So, pardon me, it's the other way around, right? R equals then L over tau. So then L is 31 times 10 to the power negative 3 henries over 1.85 times 10 to the power negative 3 seconds that we just calculated. Our resistance is then 16.76 ohms.